Hello students, welcome to the class. I am Dr. D.S. Veena, Associate Professor in the Department of Basic Science and Humanities, B.V. Raju Institute of Technology, Narsapur. Course name, Linear Algebra and Calculus. Topic name, Applications of First Order Ordinary Differential Equations. So today we are studying about applications of first order ordinary differential equations. So students, do you know when a hot metallic ball is immersed in a cold water, what happens? The temperature of the body decreases. That is, the temperature of the ball decreases. So this states the Newton's law of cooling. So today we are studying about the applications of first order ordinary differential equation, that is Newton's law of cooling. Newton's law of cooling. Newton's law of cooling. So what it states is nothing but the rate of change of temperature of a body is proportional to the difference of the temperature of the body and the surrounding medium. So once again I repeat, the rate of change of temperature of a body is proportional to the difference of the temperature of the body and the surrounding medium. Statement. The rate of change of temperature of a body is proportional to the difference of the temperature of a body and that of the surrounding medium. Okay, so let us take theta as temperature of the body at any time t, and let us take theta naught as temperature of the surrounding medium. So the surrounding medium may be air or water. Okay. So the statement states that the rate of change of temperature of body is proportional to the difference of the temperature of the body and the surrounding medium. So mathematically we can write it as d theta by dt is proportional to theta minus theta naught. Okay. So we can d theta by dt is equal to minus k theta minus theta naught. K is nothing but the proportionality constant. Here k is positive constant. So students, why we have taken this negative? Because the temperature is decreasing. Now we will solve this problem by using variable separable. So d theta by theta minus theta naught, we can separate the variables, minus k dt. Now all the theta is separated with d theta and t with dt. Okay, so now integrating both sides, d theta by theta minus theta naught is equal to minus k dt. So this is nothing but integration of this term is nothing but log of theta minus theta naught is equal to minus kt plus c. So this is the formula to solve the Newton's law of cooling problems. So remember, what is the formula? Log of theta minus theta naught is equal to minus kt plus C. Remember this equation 1. So remember students, in each and every problem we have to prove this all and then solve the problem. So let us go to problems. Let us take first problem. Example, a body is originally at 80 degrees centigrade and cools down to 60 degrees centigrade in 20 minutes. If the temperature of the air is 40 degrees centigrade, find the temperature of the body after 40 minutes. Okay, so a body is originally at 80 degrees centigrade and cools down to 60 degrees centigrade in 20 minutes. So initially it is 80 degrees centigrade and it cools down to 60 degrees centigrade in 20 minutes. If the temperature of the air is 40 degrees centigrade, that is the surrounding media air is at 40 degrees centigrade, then we have to find the temperature of the body after time passes up to 40 minutes. So what is the temperature of the body you should find? So let us take first of all the statement of Newton's law of cooling. So what is the statement? We know first always you should write the statement. d theta by dt is proportional to theta minus theta naught. Okay, where theta is nothing but temperature of body at any time t and theta naught is nothing but temperature of what is the surrounding media? Temperature of what is the surrounding media here? Air. Surrounding air, that is 40 degrees they have given. So what do you get here? d theta by dt can be written as minus k theta minus theta naught. Now separate the variables. D theta by theta minus theta naught is equal to minus k dt. Integrate on both sides, we get d theta by theta minus theta naught is equal to minus k dt. So integration is nothing but log of theta minus theta naught is equal to minus kt plus c. So this is the formula you have to use in the problem. Take this equation as now. Now what is the surrounding media they have given? Given is theta naught, given as 40 degrees centigrade. So substitute in 1. So substituting, what do you get? Substituting in equation, what do you get? Log theta minus 40 is equal to minus kt plus c. Take this equation as 1. Now one by one you go on substituting and you have to find the temperature at 40 minutes. Okay. Now here constants are k and c. First you should find the constant k and c by given conditions. What is given? Given initially the temperature is 80 degrees centigrade. Initially means we have to take time as 0. So T is equal to 0. What is the temperature they have given? 80 degrees centigrade. So substituting in 1. So what do you get here? Log 60 minus 40 is equal to minus k into 0 plus c. So what do you get? Log 20 is equal to, sorry, what is that? What is the temperature of the uh, body initially? T is equal to 0, temperature is 80 degrees. So it is nothing but log 80 minus 40 is equal to minus k into 0 plus c. So you get log 40 is equal to c. So we have got c as log 40. We got the value of c. Now we have to find the value of k. So how to find the value of k is nothing but again substituting everything in equation 1. So after 20 minutes, the temperature of the body reduces to 60 degrees centigrade. So at T is equal to 20 minutes, what is the temperature of the body reduces to 60 degrees centigrade. Substituting in 1. So what do you get? Log 60 minus 40 is equal to minus k into 20 plus c. C value, you know that. What is c value? Log 40. So what do you get? Take this to LHS. So what do you get? This as log 60 minus 40 is nothing but 20 is equal to minus 20k plus log 40. So now take this to LHS and this term log 20 to RHS, right hand side. So what you get? 20k is equal to log 40 minus log 20. So what do you get here? 20k is equal to, apply laws of log. Log a minus log b is nothing but log a by b. Log 40 by 20. So this 20, 0, 0 get cancelled, 2, this 2, we get, what do you get k value now here? K is equal to 1 by 20 log 2. K value is 1 by 20 log 2. Now we got both k value and c value. Now what they have asked, at time t is equal to 40 minutes, what is the temperature of the body? You should find what is the temperature of the body. So substituting in 1. So what is the 1 value? Log theta minus 40, that is theta minus 40 is equal to minus k. What is k value you have got? Minus kt. What is k value? 1 by 20 log 2. And what is t value? 40 minutes. So 40 by 20 log 2 plus c. What is c value? We have got log 40. So what do you get here? What all get cancelled here? 0, this get cancelled 2 times. Okay. So take this to, what do you get here? Log theta minus 40 is equal to, apply laws of log 2 to power of minus 2 plus log 40. So what do you get? Log theta minus 40 is equal to log 1 by 2 square, that is 4 plus log 40. You know that laws of log is nothing but log a plus log b is nothing but log a into log b. So you can apply this log theta minus 40 is equal to log 1 by 4 into 40. So what do you get here? This get cancelled to 10. Okay. So now remove both side log. So what do you get here? Theta minus 40 is equal to 10. So this implies theta is equal to 10 plus 40. So what is theta? That is nothing but 50 degrees centigrade. So as the time reduces to, that is increases 40 minutes, the temperature reduces to 50 degrees centigrade. So this is the answer. Did you understand, students? Now we'll move to next problem. So in this type, in Newton's law of cooling, we have two types. One, same conditions they'll be giving. One, they'll give time and they'll ask temperature, and another they'll give temperature and they'll ask time. Okay, we'll go to next problem. Second example, if the temperature of the air is 20 degrees centigrade and the temperature of the body drops from 100 degrees centigrade to 80 degrees centigrade in 10 minutes. When will be the temperature when will be the temperature 40 degrees centigrade. So they have given the temperature, air temperature as 20 degrees centigrade. The body drops from 100 degrees centigrade to 80 degrees centigrade. That is, initially it is 100 degrees centigrade and it reduces to 80 degrees centigrade after 10 minutes. So they have asked when will the temperature reduces to 40 degrees centigrade. So you have to find time here. So what is the solutions here? The condition is same. Newton's law of cooling, d theta by dt is proportional to theta minus theta naught, where theta is temperature of the body and theta naught is nothing but the temperature of the surrounding medium. Here surrounding medium is air. We get it as d theta by dt is equal to minus k theta minus theta naught. So separating the variables, we get d theta by theta minus theta naught is equal to minus k dt, integrating d theta by theta minus theta naught is equal to minus k dt. So we get log theta minus theta naught is equal to minus k t plus c. So this is the formulas to find Newton's law of cooling problems. Okay, now we have to take. Now what is the given conditions here? What is the medium temperature? Air given is theta naught is equal to 20 degrees centigrade. So what do you get here? Log theta minus 20 is equal to minus kt plus c. Take this equation as 1. So because 20 is common everywhere. Okay. Now initially what is the temperature of the body? 100 degrees centigrade. So initial means at T is equal to 0. What is the temperature of the body? 100 degrees centigrade. 100 degrees centigrade. So substituting in 1. Everything should be substituted in 1. So we get log 100 minus 20 is equal to minus k into 0 plus c. So what do you get? Log 80 is equal to c. So this is c value. We got c value as log 80. Okay. Now this next condition, what after the time passes 10 minutes, the temperature reduces to 80 degrees centigrade. So let us at t is equal to 10 minutes. What is the temperature reduces to? It reduces to 80 degrees centigrade. Okay. So what do you get? Substituting in 1. So what do you get? Log 80 minus 20 is equal to minus k into 10 plus c. What is c value got? How do you know? It is log 80. Log 80. So what do you get here? Log 60 is equal to minus k into 10 plus log 80. Now take this k into 10 to LHS and this log 60 to RHS. So you get 10k is equal to log 80 minus log 60. So apply the laws of log. Log A minus log B is nothing but log A by B. So log 80 by 60. So what do you get here? The 0, 0 get cancelled. This is 2 3s are, 2 4s are. So what do you get K value? K value is nothing but 1 by 10 log 4 by 3. So you got C value as log 80 and K value 1 by 10 log 4 by 3. So now we got both the values. Now you should find what they have asked. So when does the temperature of the body reduces to 40 degrees centigrade? So at what time the temperature reduces to 40 degrees centigrade? Substituting in 1. So what do you get? Log 40 minus 20 is equal to minus k. What is k value? You know that. What is t? You have to find. T by k values 1 by k values 1 by 10 log 4 by 3. So minus k. T is kept as it is. K 1 by 10 log 4 by 3 plus c value is nothing but log 80. So take this to LHS and this to RHS. First solve, simplify this. Log 20 is equal to minus t by 10 log 4 by 3 plus log 80. So take this term to LHS, left hand side, and this to RHS, right hand side. So t by 10 log 4 by 3 is equal to log 80 plus log 20. Minus, sorry, it will be minus. Okay. So you get t by 10 log 4 by 3 is equal to log A minus log B is nothing but log A by B. So you get log 80 by 20. So log 80 by 20. So this 0, 0 get cancelled. This 2, 4, 2 ones are 2 4s are. Now cross multiply this here. So t is equal to what you get? 10 log 4 by log 4 by 3. So if you use the calculator and solve it, we get t value as 4.82 minutes. Use the scientific calculator and solve this, and ln, that is log to the base c, you solve, you get t is equal to 4.82 minutes. So after the time reduces to increases to 4.82 minutes, then the temperature of the body reduces to 40 degrees centigrade. So next we will go to the next application, that is natural law of growth and decay. So law of natural growth and decay. So next application is nothing but law of natural growth and decay. So you know that if you want to find the growth of a population in any area, or if you want to find the growth of a bacteria in a culture, we apply this law of natural growth. Okay, so what does when we'll apply decay is nothing but if you want to find the radioactive decay in a radioactive materials, there we apply the law of natural decay. So how does this state? It is nothing but the rate of change of amount of substance X at any time t is proportional to the amount of the substance present at that time. Once again I repeat, the rate of change of amount of substance X at any time t is proportional to the amount of the substance X at that present at that time. Okay, so let me write the statement. The rate of change of amount of substance. So let us take the amount of substance as X. The rate of change of amount of substance X at any time T is proportional to the amount of the substance X present at that time. So how it states, the rate of change of amount of substance X at any time T is proportional to the amount of the substance X present at that time. So mathematically, how will you write it? The rate of change, that is dx by dt, is proportional to the amount of the substance present at that time. So amount of the substance of what you have taken? X. Okay, so this is the statement for mathematical statement. So now growth will take positive, and for decay will take negative. So first I'll write for growth dx by dt is equal to kx. K is here nothing but positive, and it is called proportionality constant. So use the variable separable here. Dx by x is equal to k dt. So we have separated all x with dx and dt separated. So now integrating both sides, dx by x is equal to k dt. So you get log x is equal to k t plus c. So this is the formula for growth. Log x is equal to kt plus c. Here, since it is a growth, we will take positive. Here plus. Yes. Next we will write the decay. Decay formula. Since it is a decay, we will take negative. Dx by dt is equal to minus kx, being k greater than 0. So separate the variables all x with dx and dt separated. So dx by x is equal to minus k dt. Integrating on both sides. So dx by x is equal to minus k dt. Okay, integrating. So what you get? Integration of dx by x is nothing but log x is equal to minus k t plus c. So this is the formula for decay. So this is the formula for growth, and this is the formula for decay. Okay, so in each and every problem we have to prove this all and then solve the problem. So we'll solve the problems. Let us take one example. The number n of bacteria in a culture grew at a rate proportional to n. The value of n was initially 100 and increased to 332 in 1 hour. What was the value of n after 1.5 hour. So the number n of bacteria in a culture grew at a rate proportional to n. Here x is number amount is taken as n. The value of n was initially 100. That is, initially means the time is taken as 0. Initially it was 100 and increased to 332 in how many hours? In 1 hour. So what was the value of n? That is the amount of bacteria n after 1.5 hour. We have to find n. Okay. So this is, since the bacteria is growing, we have to use the law of natural growth. So what is the formula? You know, the dx by dt. So in place of dx, what you have to take here? N. dn by dt is proportional to n. Okay. So now since it is growth, so dn by dt is equal to kn. Now separate the variables. dn by n is equal to k dt. All n with dn and dt. Integrating on both sides, dn by n is equal to k dt. So you get log n is equal to k t plus c. So this formula you should use. Take this equation as 1. Okay. Now what is given that? Now here what are the constants? K and C. We have to find the constant K and C by using given conditions. Okay. So what is initially? Initially the number was 100. Initially means you should take at t is equal to 0. N was how much? 100. So substituting in 1. So what do you get? Log 100 is equal to k into 0 plus c. So what you get here? C value as log 100. So we got the c value. Now we have to find the k value. Okay. Now what is when as the time passes 1 hour, the number of bacteria increases to 332. So at time t is equal to 1 hour, what is the number they have increased to? 332. So now you substituting in 1. So what you get? Log 332 is equal to k into 1 plus c. What is c value? Substitute log 100. Now take this to LHS, left hand side. So k value what do you get? Log 332 minus log 100. So what do you get? K is log a minus log b is nothing but log a by b. So you get log 332 by 100. So you got k value now. Now you should find after 1.5 hour what will be the number of bacteria increased. So what do you get? So what do you get here? At t is equal to 1.5 hour, what is the number of bacteria increased? Substituting in 1. So what do you get? Substituting 1, log n is equal to k. What is k? Log 332 by 100. So what is the time? We can write this as taking 1 and a half is nothing but 3 by 2. So what do you get? Nothing but kt. K is nothing but, so kt, that is 3 by 2 log 332 by 100 plus c. What is c? Log 100. So what do you get? Log n is equal to log a plus log b is nothing but log a into b. So we can write this as log 332 by 100 whole to power of 3 by 2 into 100. So you get, remove log on both sides, we get n is equal to 332 whole to power of 3 by 2 divided by 10 square whole to power of 3 by 2 into 100. So this 2 to get cancelled, we get n is equal to 332 whole to power of 3 by 2 divided by 1000 into 100, because 10 cube is nothing but 1000. So 0 0 get cancelled. So you get n is equal to 332 whole to power of 3 by 2 divided by 10. So answer is nothing but 605. So this is the number of bacteria increased after 1.5 hours. So this is the answer. Next example 2. If radioactive carbon 14, the carbon name is 14, has a half life of 5750 years, what will remain of 1 gram after 3000 years. So now, if a radioactive carbon 14 has a half-life of 5750 years, what will remain of 1 gram after 3000 years? So the radioactive, this is radioactive, means you are coming across radioactive decay. So half-life is 5750 grams. Half-life means the mass reduces to amount, that is mass reduces to half. Amount, if you take it as n, it reduces to half, means n by 2. Okay. So what will remain of 1 gram after 3000 years? So after 3000 years, how much will be remaining from 1 gram? They have asked. So we have to take the initial amount of radioactive carbon 14 as 1 gram. Okay. So now since it is a radioactive decay, we have to take the radioactive natural law of decay. So what is that? dx by dt is proportional to x. So since it is decay, dx by dt is equal to minus x. Okay, so we are taking the amount of radioactive carbon as x itself. So separating the variables, dx by x is equal to minus k dt. Integrating on both sides, dx by x is equal to minus k dt. So integration of dx by x is nothing but log x is equal to minus k t plus c. So we should take the same formula. So since it is decay, we should take negative here. Okay. So now initially we have to take the amount of radioactive carbon 14 as 1 gram. At t is equal to 0, take this equation as 1. X, or what is the amount? Is 1 gram. Okay. So substituting in 1. So what do you get? Log 1 is equal to minus k into 0 plus c. So 0 is equal to c. So this implies, what do you get? C value? 0. Log 1 is nothing but 0. So we got c value. Now the half-life of the carbon 14 is 5750 years they have given. So half-life means the mass reduces to half of the mass, that is half of 1 gram is nothing, 1 by 2 grams. How many years it is? 5750 years. So at t is equal to 5750 years, what is the time? Mass reduces to 1 by 2 grams. Half-life. So substituting in 1. So what do you get? Log 1 by 2 is equal to minus k into 5750 plus c. What is c value? It is 0. So now we can take K value. What is K value? K is equal to minus 1 by 5, 750, 5750 log 1 by 2. So since it is minus, we can write this as applying the laws of log is equal to 1 by 5750 is nothing but log 2. Okay. So log 2, this is the value of K we have got. Now what they have asked the condition, we have to find what amount of the radioactive carbon remains from 1 gram after the time after the time is 3000 years. At t is equal to 3000 years, what is amount of carbon remains? So substituting in 1. So what do you get? Log x is equal to minus kt. So already you know t is 3000 and k is how much? 1 by 5750 into log 2. So 3000 by 5750 log 2 plus c. What is c? Is nothing but 0. Now, what do you get here? Log x is equal to, we can apply the laws of log 2 to power of minus 3000 by 5750. So remove log on both sides, you get x is equal to 2 to power of minus 3000 by 5750. This much is the grams remaining after the time passes up to 3000 years. So if you calculate by using scientific calculator, we get 0.697 grams. So this is the amount from 1 gram it remains, that is 0.697 grams after 3000 years. So this is the answer. Okay students, we have studied 2 applications of first order ordinary differential equation, that is Newton's law of cooling and law of natural growth and decay. This is all what we have studied in this class. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.